the rest of the talk. Okay, last talk, hopefully the best one. I start with a question. How many of you have actually used the SPL? I'm actually amazed by that number. Okay, let me rephrase that. How many of you have used the SPL without going nuts? A little bit less hands. Now, this is the problem when we are dealing with the SPL, because the SPL is truly, truly awesome. Only the documentation is not so good. So when you actually want to start to do something with the SPL, which site are you going to look for? Not Stack Overflow, I mean some other site. It's like PHP.net, right? PHP really has the most awesome documentation if you don't know anything, what you want to do. Except for the SPL. So if I go to the website /SPL, I get something like this. So the introduction says, the standard PHP library is a collection of interfaces and classes that are meant to solve common problems. Right. Okay, doesn't say anything. Well, some people say this is not fair because this is the old version. That's true. Nowadays they have a new interface. So it looks something like this. It has 2 more paragraphs, or at least 2 more sentences. And there's also 1 extra user contribution on there as well. Yay! Still not helping. This is pretty much the best you get from the SPL documentation. So this is the problem. There is not enough documentation to actually use the SPL. With the documentation there isn't a lot of examples on how to do stuff with it. And sometimes they are plain wrong, not so much on the PHP.net anymore, but on blogs and everything, sometimes they don't make any sense or they are actually wrong. So today I'm going to try and talk a little bit about the things that we can make better. So how many of you have ever seen an SPL talk? Because I'm not the only one who does talks like this. A few. Okay, some of them actually doing SPL talks. So most of these talks are about 5 different things. They're about interfaces, they're about iterators, they're about data structures, exceptions, and some miscellaneous functionality, because that is what covers the SPL. Today I'm not going to talk about that. I'm going to talk about all the fun and freaky stuff that is happening with the SPL inside. Don't get me wrong, there's a lot of things that will be WTF today. However, I don't want to scare you away from the SPL, but I want to demonstrate you that if you want to use the SPL, there are things that doesn't make always sense, and I want to help you with that and see if we can cover the bases. So let's start with the interfaces, because this is probably the most important part of the SPL. How many of you know about the traversable interface? Good. How many of you actually tried to implement one? How many of you succeeded? Okay. I'm not going to discuss that. The thing is, traversable from a PHP user point of view cannot be implemented. There's a star because it can, but for us it can't. So what's the point? Well, you can detect traversable interfaces. So you can use things like instance of to detect if an object is traversable or not. Why do we need traversable? Because if you're going to do for each on a traversable object, then it does magic things. With the magic things, I mean you can completely customize the way how for each iterates over something traversable, which is really awesome because you can do all kinds of really cool stuff with it. But again, traversable we cannot implement directly. However, there's something else we can do. We can use iterator. Iterator is an interface. This is basically our userland interface to make an object traversable. So if you want to do a traversable object, we use iterator interface for that. And the iterator interface has 5 different methods: current, key, next, rewind, valid. They make pretty much sense if you know how for each works. This pretty much makes sense. Now, besides an iterator, they can be, not really, but they can be grouped in two different forms. So first of all, we have something called filter iterators. And filter iterators are really nice because a filter iterator can get another iterator and filters out the outcome. So what you can do, for instance, is say, I want to filter out every second element of an item. So if we have an iterator that iterates over the alphabet, we can we can filter it through a filter iterator that says, I want only the A, I want only the C, I want only the E, etc. So you can do all kinds of really, really cool stuff with that by filtering out elements through filter iterators. Another fun thing is that you can actually chain them together. So you can have multiple iterators that all works with the output of the iterator above. Another type of iterator, we're not going to use that a lot right now, is called the iterator aggregate. So an iterator aggregate is something that is also an interface, but isn't an iterator by itself, but can be used as an iterator because it knows how to get an iterator. So what happens there is that if you want to iterate over an object that is that implements iterator aggregate, what you can do here is saying, okay, I want to iterate over this object. I'm not an iterator myself, but I know how to get it. This is mostly before doing things that have objects that aren't iteratable by itself, but can fetch external iterators. Okay, so as an example on how to use iterators. Can anyone read this code? I think you all pretty much understand what this says here, right? We open a directory, we read files from that directory, and we print every file in that directory, right? Everybody has written code like this, most probably, right? Okay, so suppose I have a new Silicon Valley startup. I have made this app, call it Awesome App 1.0. Perfect, I'm making millions out of this. Now, customer comes and says, you know what, this is all nice. I can see all the files in my directory, but now I only want to see all the MP3 files in my directory. So anyone an idea how to do that? Okay, but if you don't know about iterators, well, yeah, you use something like this probably, right? Everybody's saying, oh, I'm not doing that. Really, this is your code, deal with it. Now, so what we do is we create a hack, like, okay, this filter out only MP3 files, so we use a regular expression or something similar to filter out MP3 files. Perfect, works perfectly. However, what if we want to filter out MP3 and JPEG files? What if we want to filter out MP3 files that are larger than 6 megabytes? What if we don't want to filter at all? What if we want to search subdirectories? What if we want to search multiple directories? Yeah, legacy code, anyone? So, you get if statements, you get all kinds of really weird stuff that we deal with every day. So, we can't maintain it. We cannot even test it. Ask Sebastian about that. Really, it can't be tested. You can't maintain it. Doesn't matter if you're not the one who has to maintain it, but apparently that can be troublesome. And we can't even reuse it. That is the code, and we have to stick with that. So let's change that into iterators. So we do the same thing, only we use iterators. So even if you don't understand anything about iterators, you can understand that a directory iterator gives you an iterator that iterates over the directory, right? Now you can see that the for each iterates, and the output, so every value, is not so much the file name, but it's actually an object with all kinds of cool stuff like the path name, file information, etc. When we have that question about, can we filter stuff? Yeah, sure, we can do that. And we do something like this. So here we have the filter iterator in action, because we have the directory iterator, and we're going to feed that inside the regular expression iterator. So it will filter out everything that ends on .mp3. Does anyone see the real difference between this code and the code before? What really is changed here? Any suggestions? Yeah, but can you see that, you know, the hack we did is now not inside the for each loop, but it's outside? Yeah? So if we can see this for each loop as our business logic, and normally this is much complex than I show here, but now we can do all kinds of real cool stuff. So suppose we have the regular expression here, and we're going to feed that one into a file size iterator. It doesn't even exist, but suppose it would exist. If you create something custom yourself, you see straight away what it does. It filters out all files between 0 and 6 megabytes. What does the limit iterator do? Any ideas? Yeah, I can't make it easier than that. It really limits, just like, you know, MySQL with an offset and limit. It does the same here. So it gives you from the current directory MP3 files that are between 0 and 6 megabytes, and it will show you the 3 MP3 files starting from the 5th one, 6th actually. But still, the for each loop stays the same. You don't have to touch anything inside the business logic. It only gets a list of elements that it has to work with. Pretty neat, right? Okay, this is the most important thing about the iterators. If you understand this, you're done. So, you know, with stuff like this, that's more than enough. However, we can do things because they're more reusable. You know, we can use the iterators wherever we want, because that limit iterator does not only work on the directory stuff we have, it works on array iterators, it works on elements we get from a database, it works on, you know, whatever you get from a RESTful API. Doesn't matter. It's testable because now we can test, does the limit iterator work? Does the regular expression iterator work? Does the directory iterator work? So we can test more in isolation. It's also more maintainable because there's no need to adapt the business logic anymore. Cool. Let's talk about countable. This is really fun because this is the first official SPL interface that's on the website. The countable interface works a bit like this. So, as an example, I have an iterator, and that iterator, I leave out a bit of it, but it gets 3 elements, an array 1, 2, and 3, and then I'm going to say print count iterator. What would be the output? Any ideas? Three? No, actually it is 1. Because there's only one iterator that is actually counted here, right? There's only one object inside. When I implement countable, I need to implement a count function. What will happen now? I use 5 elements in here. What would be the output of count? 5. Yeah, exactly 5. Because what count does, count sees that if you are counting an object, it will detect if that object implements countable, and if it does so, it will call its count function. So you can do whatever you want, you know, to make count do your bidding, you know, whatever you want. But there's a catch, and this is what hurts a lot of people. So I do the same thing. I have 5 elements. Again, I have my countable iterator, and I'm going to feed that into a filter iterator called the limit iterator, offset 0, number 3. So what will it do? It will give you at least 3 elements, right? So what will count be? 1. Okay, the fact that I accept every number until 10. Now actually, it will be 1. And the reason for this is that what we are counting is not my countable iterator, but it's the limit iterator. And the limit iterator does not implement countable. WTF, right? Okay, welcome to the SPL. I've got loads more of this. So these are the tricky things. These are the things that you will find out in 5 minutes of working with the SPL and will make you scream and you know, go back to Python or whatever other language you want. So yeah, this is what makes the SPL really, really hard to use. So let's talk about the iterators themselves. There are a lot. There are really cool iterators there. This is, I think this is the whole list that's currently even available in 5.6. I'm not even sure in 7 are additional interface iterators. No, huh? No. So we have things like append iterator, array iterator, all kinds of cool stuff. However, if you're going to look up in the documentation to see what a directory iterator does, it doesn't sometimes make sense. However, there's a really cool trick. I'm not sure if you've already seen it today, but this is a website called lxr.php.net. And if you look in there, this is actually the source code, the C code of PHP. If you're going to take a look in the SPL directory, there's an internal directory. And that internal directory basically gives you a PHP model of what the iterator does. So for instance, if I'm going to take a look at the append iterator in here, it's just pretty much a PHP version of what the append iterator actually is. Because the append iterator is programmed in C, but they actually modeled it through PHP first. So if you don't understand what an iterator does, you can look in here to get a little bit more familiarity with what's going on internally. But there are really crazy iterators there, like an iterator. Sounds recursive enough, right? So why aren't they calling it recursive iterator? Because there's already a recursive iterator. So there must be a recursive iterator. And yes, there is one. And there's something called recursive callback filter iterator, which was awesome if you do Scrabble a lot. I'm always winning. So, explain this to somebody who never used SPL, right? I'm going to try, sort of. So yeah, this is what sometimes makes things hard in SPL as well. So let's start with the iterator. The iterator basically does what it says. It iterates over iterable items. Actually, what it does, it turns traversable things, and things is really global here, into an iterator. I told you before that there's an iterator interface, but there's also something called an iterator aggregate interface. And the filter iterator, like the limit iterator, only accepts the iterable interface. So it's type hint as iterator. So if my iterator would be an iterator aggregate, I first have to basically convert it into an iterator by doing something like this. So if it's an instance of iterator aggregate, I get the real iterator from it. Absolutely does not make any sense, but this is the way how things work internally. So what they do is they say, okay, I got an iterator. I'm going to feed that into iterator to convert it to a real iterator. And then I can do stuff like limit iterator or chain it. So if you see iterator somewhere in the code and you have no idea why, chances are the coder of that piece of software didn't either, but saw it on the website like, just add it, and then you're mostly fine when dealing with iterators. So that happens a lot, yeah. So recursive, whatever iterator. Any idea what it does? The naming has a hint. Finally, yeah. So let's try that. So I've got an array iterator, which iterates over an array. I got an array with foo, bar, another internal array, cux, wox, and bas. So when I iterate over this, what will be the output? Foo, bar. Array. Exactly, foo, bar, array, bar, bas. Okay, so there's something called a recursive array iterator, so I use that instead, right? So at least it's recursive. So the output now would be foo, bar, array, bas. Oh my god. Now you're really going to Ruby and Go. The thing is, you have to do a recursive iterator before that. Why don't you people know this? This is because when you do this, then it works automatically. Right. So now you see why people don't use SPL. Now, here's the thing. The recursive iterators, they only add the possibility to recursively iterate over data. But you still need to implement that functionality yourself. The recursive iterator actually does that for you. So if you're really lazy, you can just throw it in a recursive iterator, and it will actually work. Why? So, to be honest, my advice for the PHP 7 people under us, stop working on PHP 7, start working on SPL. Now, this is what happens a lot in SPL. This is what makes it really, really hard to work with. So, recursive callback filter iterator. Anyone want to try? Everybody's like, no way, no way. Well, it's easy. So it's a recursive iterator, so it will do everything except recursively, but it gives you the possibility to do things recursively. It's a filter iterator, so it actually injects another iterator and filters out stuff, and it uses a callback for that, which is really awesome. So now what we can do is we can create a simple filter iterator by just adding a callback to it. So it works exactly as you would expect from now on. But yeah, if you start with SPL, it doesn't make any sense at all. SPL iterators, right. The thing is, there are a lot of quirks in it, but they're easily solvable, but it means, you know, BC breaks. I would really say, okay, let's give it a try on PHP 7, but, you know, the documentation is not really up to date, so that makes it really hard. The naming is very confusing. There's something called a caching iterator, which does everything except caching, literally. Well, it can do caching, but not in the way you think. There's a recursive iterator, we already discussed that one. And there's a seekable iterator, which obviously is not an iterator, but an interface. But as said you before, you know, I'm going to talk about all the scary stuff. Iterators are worth it, really, really. You have to get past this part, and if that, then they're really, really awesome. Really try it. At least you know if you hit something that you think, oh, I'm just too stupid, it's probably not you, it's SPL at that point that really messes things up. Data structures. There's also a lot of really cool data structures inside. Things like SPL doubly linked list, SPL stack, SPL heap, priority queues and everything, which is really awesome. I'm not really going to talk about that because it's way too complex to actually tell you about it. There's a really good talk about from Patrick Allard, I think, who does talk about data structures. Really recommend to see that one. The thing is, every data structure has its strengths and its weaknesses, and they can be, they are basically a trade-off between, you know, how much time and how much memory does something use. So one data structure can be really, really fast, but takes up a lot of memory. Some data structures are really small memory-wise, but takes a long time to find items or to add items or whatever. The thing is, PHP arrays are really good. They are really, well, for most cases, they are the best data structure you can use because internally they are stored in a way that's, you know, has a really good time and space trade-off. So if you don't know, please use arrays unless you really benchmark whatever you're doing. So don't say, oh, you know what, we want to do like all kinds of really freaky stuff with arrays, just use SPL fixed array. Well, you can, but that's a really good way to shoot yourself in the foot because it has its uses, but you really have to understand how it's being used and how it's working internally. Patrick also does a really cool thing. It's like more of a pub quiz about the different data structures that are inside. So as a example, I just want to show you some as well. I want to see if you can guess which kind of data structures these are. So which one am I actually? Yeah, easy enough. This is a stack. This one? SPL crowd, yeah. No, it's actually SPL queue. Sort of. I have to apologize for my Dutch fellow members for this one. Yeah, SPL drunk linked list, but this is an SPL linked list, but then again they're using both hands, so doubly linked list in my case. This one, SPL object storage. It exists. My favorite, especially when I'm flying a lot. SPL priority queue. This one is SPL tree. Now actually this is an SPL heap, because SPL heap internally uses a tree system. I could use another type of heap, but that would not be appropriate for this conference, I think. This one. Already talked about that one. SPL fixed array. Well, they actually told me, no, that's not true, because those satellites can actually move a little bit. Well, that might be true, but you're not probably picking them up and taking them away. So it's fixed enough. The thing is, with the SPL data structures, really use them wisely. Don't use SPL stack on SPL queue when you do random reads. If you want to use element 6 and then 5000 and then 339, they're awesome if you want to do 1, 2, 3, 4, etc. So if you want to do sequential stuff, but not for random reads. So this is what you have to think about. Don't use fixed arrays when you need a speed boost, because if you look at the benchmarks, the speed boosts, they aren't there, depends on a bit what you are doing. But you have a lot of things that you get with normal PHP arrays, which you can't get with fixed arrays. So, please use them wisely. Okay, exceptions. Who is using exceptions in their code? Cool. So some of you aren't. Okay. No, that's fine. I think. Just leave your name and number. So there's all kinds of cool exceptions in the SPL. Things like bad function call, bad method call, domain exception. But there's absolutely no documentation on when to use what exception. To be honest, I tried to figure out what is exactly each exception. Pretty much nobody knows, or everybody gives a different answer. So it's a bit strange. The thing is, these exceptions are based in two categories, in logic exceptions and in runtime exceptions. I'm really glad if you're going to use a runtime exception when you need to throw a runtime exception, and if you throw a logic exception when you need to throw a logic exception. So as an example, this is a function call. If the string is the Spanish Inquisition, you throw a new unexpected value nobody expects. Takes a while. However, this is false, because unexpected value exception is a runtime exception, and you need to add a logic exception here. So it would be invalid argument exception. So nobody was expecting that, right? Enter the. Oh no. So the thing is, in this case, it should have been a logic exception. Now, what is the difference between a runtime and a logic exception? What I always say is that if you, as a developer, have control over the exception, it's logic. If you don't have any control, it's runtime. For instance, in this function, so the string Spanish Inquisition invalid argument exception, That is a logic exception because you as a programmer have control over what you call the foo method with, right? At least I hope you don't just get user data in there. But then again, if we have like a save record here that saves a record into the database, you know, what's happening? The database could be full, offline, on fire, stolen, you know. So there's all kinds of exceptions that can happen outside of the control of the developer. Those cases, you know, a runtime exception could occur. And what happens, or what could happen in this case, suppose it takes a user 5 minutes or 15 minutes to enter a form, goes to save record says, oh, sorry, runtime exception because there was a lag in network traffic or whatever. Go back and fill out the form again because I didn't save it. You know, what could happen here is that if this thing throws a runtime exception, okay, so let's wait a second, try again. Do that 5 times, and then say to the user, listen, I tried 5 times, and you know, the database is still on fire. Sorry, but I can't save it. Or you can do things like, you know, pull it back into a queue and save it later or whatever. So with the help of things like runtime exceptions and logic exceptions, you can actually, you know, not say, oh, an exception has occurred, bam, error, but you can actually try to recover from certain errors. And this is why things like runtime exceptions are really cool. Clear? Sorta, kinda? The thing I always recommend is never throw exception, because if you throw the general exception, you are like the same guy of the same customer that goes into your bug tracker and says, oh, the site doesn't work, please fix, enter. You know, something is wrong, that you know, but there is no information about what's wrong, you know, what happened whatsoever. So please do not do that. But always catch exception one way or another, because there are always, the nice word, idiot, there that actually throws exceptions when they should have to do things like runtime exception or logic exception or whatever. So at least catch them, but never throw them. The SPL has got all kinds of miscellaneous functionality. Things like SPL autoloading, which we don't really have to deal with anymore because everything is Composer right now, hopefully. They have things like SPL file info classes, which is really awesome because the directory iterator, etc., uses SPL file info classes. So you get all the file functionality inside a neat object. The same thing with SPL file object, which have the actual file inside. So you can do things like reading and writing directly on objects. You have things like array objects, and you have even interfaces like SPL observer, SPL subject to create the observer design pattern and everything. Well, they have their uses, but you don't see it really a lot. There's a real cool thing with the autoloader. Anyone ever used the autoloader from SPL? Cool. Okay, so for those of you, what does this do? So the thing is, SPL autoload register can register a function just like __ autoload is onto, you know, the SPL autoload stack. The SPL autoload call function is the default autoloader that SPL uses. So what would happen if you register the default autoloader? That results, in this case, in a logic exception, which makes sense because, you know, it's already there, so there's no need to register it. Okay, so what does SPL autoload unregister do? Throws an error, exception. Fun thing, it removes all the autoloaders, it destroys literally the autoload stack, and it sets your house on fire. Don't even try it. It's literally in the SPL source code. If the argument is SPL autoload call, destroy the whole stack, actually remove all the autoloaders. I'm not sure if this was like debug stuff left over, because in my opinion, it shouldn't be there. It's there. I don't think it's documented well because it literally does not work. I've spent like a few times dealing with this issue myself, so this is why I want to, tell you about it. But all kinds of really, really freaky stuff. Anyone working with array objects? They're cool, right? So array objects are objects that act like array, but in the same time, they are not objects that act like array. They work a little bit differently. And the thing is it's really subtle, but it's a big difference. It can make a big difference. So as an example, I have an array with foo and bas. I say variable $b is $a. I add something to b. What will be a? What will be b? Any ideas? Foo and bar on a, foo bar bas on the b, right? Because what happens is a and b points to the same variable, but because we add something to b, it's a copy on write action. It actually splits out the two arrays into two separate variables. So the a is left alone and the b will be added bas. Okay, this makes sense. However, if we use an array object, from a user point of view, it looks pretty similar like arrays. You can use the square brackets and all. So I add foo bar to a. I do the same thing. I assign a to b as well. I add something to b, and what do I get? Foo bar bas, right. So even if you use, and I know some frameworks really like to hide the fact they are using array objects, it can mess up your whole day, week, code, whatever. Because what happens here, they are basically the same object. So they are referencing the same object, and they're not split as soon as you change something. So you have to be really, really careful with stuff like that. So how can we make the SPL easier? Because everything I told you does not really want you to, make use of the SPL. There's a really good way to do that. I've written a book about it. I can actually say it's the first and only book about SPL. No, it's it in detail describes everything that should be in the documentation, but also gives you all this kind of freaky stuff. So at least you don't have to trip over it. However, commercial stuff aside, adoption of the SPL will only happen when developers can become more familiar with it. How old do you think SPL is? Like 3 years old? So that's like 10 years, 10 plus years. No, that's a long time. There's absolutely no reason. I understand when you can't say, okay, I can't move to PHP 5.5 because of, hosting. You can use the SPL right now. So you can, create a pull request right now, put it in production. As of now, it works. But we can only make it happen if people are more acquainted by it, and there is no real way to do that because the documentation sucks. The blog posts are minimum and aren't really that good. So here's the thing. If you're going to use the SPL just to see if all the freaky stuff really is true, what I say today, blog about it. The more people blog about it, the easier it is to find, even, post it on Stack Overflow, I don't care. Update the documentation, because you can do that now yourself with the user contribution notes. And if you know a bit about C and everything, you can even find the quirks and maybe even solve them yourself. Most of the time it's that simple, but nobody really takes the effort to do that. That's a bit of a shame. So these things you can do yourself right now. Cool? Any questions? Too much. This one? I would use the percentage, the ampersand. What do you call it? Ampersand. Yeah. So you say B is, the reference is, and then you have, oh, sorry. It's completely, no, sorry. B is clone A. Yeah, sometimes I even get confused. No, in this case, B is clone A because you get two separate objects in that case, right? That's why I could not pronounce ampersand, because it's... Okay, any more questions? I see somewhere in the lights.
Yeah.
Yes?
I was wondering, why is this an extension? Shouldn't this just be a library?
Why is it an extension? It started out as a library, as a PECL, I think. Pair. It started out as a pair, and then
So the point of this, it's a technical decision basically. To put it, so from PHP's core architecture, everything is an extension basically. Very few things are part of the core engine. There are few things which have to be there, but everything has some form of an extension.
I think about 5.1 they decided.
Until 5.1, you could disable SPL, but as compilation time. Since 5.2, I don't know if it's exactly 5.2 or something like that, you always have SPL enabled by default, and it's no difference if it would be another place, code base of PHP.
Yeah, and the thing as well is that there are things in SPL like the traversable and everything that's also used on other parts of the system. So like datetime uses traversable, simple XML uses traversable as well, and that code is actually inside the SPL extension. So it's a bit interwoven nowadays. So, but I think it's a good thing, because if the SPL is always enabled, people should use the SPL. But okay, one more. Well, the SPL fixed array is more like what you see as an array on the C level. It reserves a certain amount of slots for you that you can use. So it doesn't grow dynamically. You can make it grow, but you really shouldn't. And
the benefit is that it takes less space per element. So you save memory.
yeah, what?
So exactly, that's the maximum size of elements. Allocates and condense a smaller buffer, holding just the values accepted. And it doesn't need space for the meter data for which the hash table, which is PHP's array usually needs.
Yeah. And what happens then is because it's more compact, you cannot use string keys. It's all numeric indexation. So you are missing a lot of optional and additional stuff. And it really depends. You really should benchmark to see if it really has more memory or less, because it really depends on your situation. Okay? Any more? Okay. Thank you.